Hello friends, welcome to YouTube channel GG Civil Academy. In this video, I'm going to take problems on bars of varying section. So this is the figure of the problem. This is the statement. Find the total elongation of the bar as shown in figure for an axial pull of 40 kN. Take E equals to 140 GPa. So this is the figure which is having three different diameters 30 mm, 20 mm and 40 mm, which is connected with 40 kilonewton axial pull force. Okay, so with different length also 180 mm, 260 mm and 160 mm. So we need to calculate the total elongation of the bar. Material is same. How we are going to identify this? Because modulus of elasticity which is given here, that is same. That is they have mentioned that take E equals to 140 GPa. It means that E is same, means the material is same. So only the difference is diameter is different. So we need to calculate elongation of the bar. So we know the formula delta L equals to PL upon AE. So what we will do, we will add the different elongations of this different diameter of the bars. So definitely we will get the total elongation. So this is the axial pull force. So this is the statement of the problem. So we need to calculate the elongation. So now P is equals to 40 kilonewton, which is converted into Newton, and E equals to is in GPa, which is converted into MPa. So L1 is equals to 180 mm, L2 equals to 260 mm, L3 equals to 160 mm. So diameters are given 30 mm, 20 mm and 40 mm. So you can pause over here the video and you can calculate the area. Diameter is given, so definitely A1 equals to pi by 4 D1 square, A2 equals to pi by 4 into D2 square, A3 equals to pi by 4 D3 square. So pause here the video and calculate the areas and cross check with it. So I already told you delta L equals to delta L1 plus delta L2 plus delta L3. So delta L how it is calculated? PL upon AE. So PL1 upon A1 E1 plus PL2 upon A2 E2 plus PL3 upon A3 E3. So here modulus of elasticity is same. So E1 equals to E2 equals to E3. So definitely P by E we can take common, and in the bracket L1 upon A1 plus L2 upon E2 plus L3 upon E3. So like that delta L they have written 180 L1 upon A1, L2 upon A2 and L3 upon A3. So you can cross check the values of A3. This is A2 and this is A1. So this is P value, this is given. E value is also given. So calculate delta L here, pause the video, calculate it and then cross check with the final answer of delta L. So this is very simple problem of on bars of varying section. Now this is the problem number 2. So a composite bar ABCD is loaded as shown in figure. So this is the figure. A composite bar means it is definitely with different materials. So this is here A, B, C and D. So as shown in figure, if the bar contracts by 1 mm, so bar contracts by 1 mm, they are mentioned. What are the stresses induced in different materials? Given cross-sectional area, they are given the areas of it. Area of copper material, area of aluminum and area of steel material bar. So 100 mm square is for steel, aluminum 300 mm square and for copper 200 mm square. Take EC equals to modulus of elasticity of copper equals to 10 to the power 11 Newton per meter square. Modulus of elasticity for aluminum bar 0.7 into 10 to the power 11 Newton per meter square, and modulus of elasticity for steel equals to 2.1 into 10 to the power 11 Newton per meter square. So you need to convert this as in Newton per mm square. Okay. So we will go for the solution. In this problem, basically what we need to find out? Stress. What is not given? P is not given. What is given? Length given, right? area given, so we not needed to calculate the area, they are already mentioned the areas. So we will go for what is the formula of delta L. Delta L is also given. The bar contracts means there is a compressive force, so it contracts. If there is a tensile force, it will extend. Okay, so it contracts by means 1 mm. So delta L is given. Total elongation of the bar is given, that is 1 mm. So how you are saying that there is a compressive force, because the statement is showing contracts and the action of P is also compression. So it is a compressive force. Okay. So now we will go for the solution part. So P is not given. So you need to convert first this EC, EA and ES. So it should be in Newton per mm square. So you just divide it by 10 to the power 6 because it is in meter square and mm square. So 10 to the power 6. Then it will come 10 to the power 5. So EC is equals to 10 to the power 5 Newton per mm square. Like the same EA and ES you calculate. So LC equals to 100 centimeter, LA is equals to 50 centimeter and LS is equals to 75 centimeter. How? See, 100 centimeter, 50 centimeter and 75 centimeter. They are mentioned in the problem. Now, the lengths are given, modulus of elasticity are given. What is the formula of delta L? Delta L is equals to PL upon AE. So total elongation we know that. So that it should be written. This AC, AA and AS is also given. This is mentioned in the problem. Now delta L is equals to delta LC plus delta LA plus delta LS. So yes, here we can write like this: PLC upon AC EC plus PLA upon AA EA plus PLS upon AS ES equals to delta L. So now I will write here 1 mm, which is given by the problem itself, and P is unknown. LC, LA and LS, it is written over here. AC here, AA here, AS here. So EC, EA and ES we have mentioned over here. You need to convert it. Okay. So we will get definitely the P value by equating to 1. Why 1? Because they have mentioned the bar contracts by 1 mm. So this is the bracket and the values are here. So you can pause here and calculate the value of P. You can write here 1. So definitely you will calculate over here P value, and pause here the video and check the P value. So the P value is 9130. 9130 is the value, 9130.43 Newton. So stress we need to calculate. What is mean by stress? Stress equals to P upon A. So for that particular bar, that bar's area. So for copper, we need to divide it by copper area. What is the bar of the copper area? That is 200. That is given in the problem. So P value we got it. So definitely P value will be the same for copper, aluminium, steel. This is the copper. See, for copper, for aluminium and for steel, this P value will be the same. Only we need to divide it by different areas. So go again for the yes. So P upon AC. Here you can pause. You can calculate it and you can cross check with the values. Thanks friend for watching this video. If you liked my videos, please subscribe to the channel GJ Civil Academy. Thank you so much.